Today we're diving deep into the captivating universe of artificial intelligence. This revolutionary technology has been a game changer, altering the way we live and work. But have you ever pondered about the various stages that have marked AI's evolution? Join us as we unravel the enthralling progression of AI, from its modest inception with rule-based systems, all the way to the exhilarating possibilities of artificial general intelligence. Let's begin our journey with the first step in the evolution of AI, known as rule-based systems, or expert systems. This stage was our initial attempt at mimicking human decision-making using a set of predefined rules or heuristics. Think of it as a colossal flowchart, where every decision an AI makes is based on a rule like, if this, then that. One of the earliest applications of rule-based systems was in the field of medical diagnosis. MySyn, developed in the 1970s, was one such system designed to identify bacteria causing severe infections and recommend antibiotics. It used a set of about 600 rules to identify the bacteria and suggest treatment, providing a significant advancement in medical technology at the time. Similarly, industrial process control systems widely used rule-based systems to manage complex manufacturing processes. These systems monitored various parameters, like temperature or pressure, and made decisions based on predefined rules to ensure optimal and safe operations. However, these rule-based systems were rigid, bound by their predefined rules. They couldn't learn or adapt to new information or scenarios, which severely limited their potential applications. For example, if a new bacteria strain emerged that MySyn's rule set couldn't identify, it would fail to provide an accurate diagnosis. This lack of adaptability was a clear limitation and a significant motivation to move forward to the next stage of AI evolution. Moving beyond the constraints of rule-based systems, we find ourselves in the second stage of AI evolution, machine learning. Here, rather than simply following rigid, predefined rules, machines are now learning from data. The key difference is adaptability. Machine learning algorithms are designed to adapt and improve as they process more data. There are three main subcategories in this stage: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning operates much like a student-teacher scenario. We provide the AI with examples. These are labeled inputs and outputs, and it learns to make predictions from this data. This concept is at work in your email spam filter, a classic instance of supervised learning. The algorithm learns to classify emails as spam or not spam based on examples of both types it has processed before. Unsupervised learning, on the other hand, is more about discovery. The AI sifts through unlabeled data, looking for hidden patterns. Recommendation systems, like the ones used by Netflix or Amazon, utilize this approach. They analyze your browsing and purchasing behavior, identify patterns and trends, and use this information to recommend a movie you might like or a product you might find useful. Lastly, we have reinforcement learning, which adds a touch of gameplay. Here, the AI learns through a system of trial and error, receiving rewards or penalties for its actions. Google's AlphaGo, the program that defeated a world champion Go player, is a prime example. It used reinforcement learning to perfect its strategy, continually improving by playing millions of games against itself. Despite the impressive capabilities of machine learning, it's not without its downsides. Machine learning algorithms often require large amounts of labeled data and can struggle with tasks outside of their training data. This limitation became more apparent as we sought to process complex, unstructured data like images or human language. Our ambition to improve upon this led us to the next stage, a deeper dive into the realm of AI, deep learning. Delving deeper into the AI evolution, we find ourselves at the third stage, deep learning. Expanding on machine learning's principles, deep learning uses artificial neural networks, mimicking our brain's neurons, to process data in layers. This layered approach enables handling complex, unstructured data, taking us a step closer to mimicking human-like understanding. Deep learning can be categorized further into convolutional neural networks, CNNs, and recurrent neural networks, RNNs. CNNs are used predominantly for image recognition, and a practical example of this is Google Photos. Google Photos utilizes CNNs to identify and categorize images. You can search beach in your photo library, and the platform will pull up all your beach photos, regardless of whether they're labeled. RNNs are designed for sequential data, such as language or time series data. The most evident use of RNNs is in voice assistants like Siri, Alexa, or Google Assistant. They employ RNNs to interpret and respond to spoken language, making our interactions with them more natural and intuitive. A further exciting application of deep learning is chatbots, like OpenAI's ChatGPT. It's trained using reinforcement learning from human feedback, RLHF, and it can generate human-like text based on the input it receives. It's been used in various applications, from answering queries to drafting emails, and it's an excellent example of how deep learning can lead to innovative and beneficial AI applications. Another groundbreaking application of deep learning is in the medical field. For instance, Google's DeepMind has a system capable of diagnosing eye diseases on par with top human doctors. This tool can analyze retinal images quickly and accurately, providing invaluable support to medical professionals. Nevertheless, deep learning isn't the final stage of AI. While it excels in handling large amounts of data and making precise predictions, it also requires significant computational power. Moreover, it has a black box problem, making its decision-making process hard to interpret. These limitations inspire AI researchers to develop a more human-like form of AI, setting the stage for the next exciting phase. As we approach the current frontier of AI research, we enter the realm of artificial general intelligence, or AGI. This stage seeks to create machines capable of understanding, learning, and applying knowledge across a broad array of tasks, much like a human being, transcending the specialized intelligence of previous stages. While AGI is more a concept than reality at this point, the few glimpses we've seen of its potential are nothing short of transformative. Consider the AI program GPT-4, developed by OpenAI. Although it's not an AGI, it's arguably one of the most advanced AI we have to date. It can write essays, answer questions, translate languages, and even generate Python code. It's almost like having a conversation with a human, demonstrating an impressive range of capabilities. Another potential application of AGI is in the realm of advanced scientific research. With an AGI's ability to understand and innovate across various fields, we could witness acceleration in areas such as climate modeling, drug discovery, or even the search for extraterrestrial life. In essence, AGI could become the ultimate research assistant, capable of understanding and integrating complex information across multiple domains. Then, there's the intriguing yet controversial concept of superintelligent AI. This is an AI that surpasses human intelligence in nearly all economically valuable work. It's a captivating idea, opening up possibilities for incredible advancements, but also raising questions about ethics, control, and even survival. However, it's crucial to note that while these potential applications are exciting, AGI remains largely in the realm of speculation and research. We are still facing significant technical challenges, and ethical considerations are becoming increasingly prominent. But even as we explore these unknowns, we can appreciate the promise AGI holds for our future. Our journey from rule-based systems to AGI underscores the incredible human pursuit of knowledge and innovation. Each stage has brought us closer to the ambition of building machines that can assist us in tackling the most challenging problems of our era. As we continue to push the boundaries, it's fascinating to speculate about the future of AI. Perhaps AGI, or even superintelligence, is not as distant as it seems. Let's keep exploring this exciting world of technology together.